Talking about submarines, silence is survival. Therefore, if there is any way to make the submarine quieter and more efficient, it will be seen as revolutionary and a well-guarded secret. There is an important part of the submarine, which is kept very secret. It is a submarine's propeller, better known in the Navy as a screw. It seems so secret when a sub comes in from patrol, its propeller is shrouded with a large covering, and if a sub is dry docked for any length of time, it is commonly removed and stored away from the ship for servicing and prying eyes. Even when the sub is on land, such as during repair or launching of a new one, the propeller is tightly closed, wrapped in fabric, or some other covering is placed. This part is what actually drives a submarine quickly and quietly through the water and is absolutely critical to a submarine's stealth. The propeller is an extremely high-tech piece of equipment resulting from extensive Navy research and development. Until recently, the U.S. propeller technology is believed to exceed the Soviet Union's by a considerable margin. As a result of this and other factors, Soviet submarines of the Cold War are likely noisier, and therefore it seems easier to detect. The following are examples of some sub-launch videos in which the propeller is always tightly closed. Anyway, what might lead to the question is, why is the shape of the submarine's propeller kept a secret? What is the danger if the shape of a submarine's propeller is uncovered? Faster speed, high maneuverability, and having little noise in the water are all particular demands of military vessels. Sound waves travel great distances through the water, and the distinctive sound of a propeller seems to make a sub easy to identify among the other noises of the ocean by predatory submarines lurking beneath the waves. The propeller noise can often be so distinctive that sonar operators are able to not only identify a particular class of ship or submarine from its noise signature, but also the individual vessel. Having the ability to noise reduction, this capacity seems to be one of the most essential design purposes of modern submarines. Since the noise generated by the screw or a submarine's propeller can be used to determine the submarine's location, in which this noise is generally caused due to cavitation. Cavitation takes place as a result of changes in pressure in the water as the propeller blades rotate through it. Most people know that at normal atmospheric pressure, water will boil at 100 degrees Celsius. If the pressure drops, however, the temperature needed to turn water into steam also falls. This is why water boils at lower temperatures on top of mountains. In regard to the propeller, when a propeller spins rapidly through water, it creates high pressure on the front of the blade and low pressure on the back. While it is this pressure difference that helps to generate the thrust from the propeller, if it gets too high, the water around the blade can vaporize, generating bubbles and cavities in the water close to the surface of the blades. However, as the bubbles leave the blades, the pressure around these cavities changes, causing them to implode violently and pop. This generates a crackling noise, much like someone is repeatedly throwing stones at the bottom of the hull. The propeller or screw is a basic device that works by pumping fluid and gas. It can be seen either to have the screw rotate faster or increase its size. Making it rotate more quickly makes it noisy, and the size can only be increased to a certain extent. Meanwhile, a smaller propeller or screw rotating at higher speeds is prone to cavitation. Therefore, when it comes to the designing of submarines, the blades are designed to generate thrust while minimizing cavitation. Older submarines could manage speeds of only 2 or 3 knots while remaining silent. On the other hand, modern submarines are able to achieve speeds of 8 to 10 knots while maintaining the same noise level. The reason why the shape of the submarine propellers is kept a secret is because it can indicate the speed at which it will be rotating for the sake of remaining stealthy. If the enemy is aware of the shape and speed of propellers, the output frequency, along with the engine type and RPM, can be calculated. This leads to the enemy fine-tuning its sensors and listening to disturbances in a particular frequency range. This might drive the enemy to find out the location of the submarine even when it is not moving at its noisiest speed. For instance, if a submarine can manage 8 to 10 knots and remain quiet, but the enemy has made adjustments to its sensors for detecting the submarine's specific hardware, the enemy might up the submarine when it is operating at the speed of 7 knots. The shape, section, and pitch of the propeller alter the envelope in which the screw can work without creating cavitation. Thus, knowing this information will help the enemy to ascertain the performance of the submarine and also give them the tactical advantage of picking it up on their sensors. As a result, they will tune their passive sonar device to focus on detecting sound in that frequency range. Therefore, the enemy can more easily detect the presence and position of the submarine. For this reason, the shape of the screw or propeller of the submarine is very secretive. For the information, the main source of submarine noise, the propulsion system, is dramatically reduced with the use of sound damping mechanisms, rubber tile coatings along the entire outside hull of the sub, propeller screw design, and the use of precision computer numerical control CNC machinery capable of making much higher quality components, particularly propellers. Thanks for watching. If you find this video interesting, don't forget to like, share, comment, and the most important one is to hit the subscribe button for more updates on awesome videos.